So, what's the secret to making an AI really smart? It's not always about having the most powerful computer or the craziest algorithm. Nope. There's this secret ingredient, this thing that can absolutely make or break an AI's performance. It's called feature engineering, and today we're going to break down exactly what that is. But first, have you ever seen an AI do something incredible, like compose music or write code, and then it just fails at a task that seems super simple? It's weird, right? You're left wondering, how can something so smart get the basics so wrong? Well, there's a surprisingly simple reason for that. See, the problem usually isn't the AI's brain. It's all about what we feed it, the ingredients. Think about it like this. You could have the best chef in the entire world, but if you give them rotten tomatoes and expired flour, they're not going to make you a great pizza. It's the exact same for AI. The quality of its data completely dictates the quality of its results. Okay, so what exactly are these ingredients that an AI uses? In the world of machine learning, we've got a specific name for them. We call them features. Let's dive into that. A feature is really just one piece of the puzzle. It's a single, measurable bit of information from your data. It could be something like the price of a car, the age of a person, or maybe the pixel color in an image. Think of features as the individual building blocks of knowledge that an AI uses to understand the world around it. Let's make this super simple. Say we want to build an AI to predict a student's final grade. Well, what are our ingredients, our features? It'd be things like the number of hours they studied, their attendance record, maybe their grades on past assignments. The AI takes all these features, looks for patterns, and then makes its best guess on that final grade. And this right here is the golden rule. The quality of your features is, and I mean this, everything. How useful and clean they are is going to directly decide how well your AI performs. It's that classic saying you've probably heard, garbage in, garbage out. It's as simple as that. Better features always lead to better predictions. Okay, so if our features are the ingredients, then feature engineering is basically the art of being a data chef. And the first technique is like creating a whole new flavor from scratch. This is called feature construction. This is where things get really creative. Feature construction is all about taking your raw ingredients, your original data, and combining them to make something brand new and way more insightful. It's like taking flour, water, and eggs. They're okay on their own, but when you combine them, you get pasta. It's a total game changer. So why bother doing this? Well, sometimes the raw data just doesn't tell the whole story. By creating these new combined features, we can spell out really important relationships and patterns that the AI might have missed otherwise. And, of course, that almost always leads to a big boost in accuracy. Here's a perfect real-world example. You could give an AI two separate features, a person's height and their weight. But if you combine them using a formula to create a single feature, BMI or body mass index, you've just created a much more powerful piece of information for any model trying to predict, say, health outcomes. All right, so creating new features is cool, but any good chef will tell you you can't just throw everything you have into the pot. You've got to pick only the best ingredients. And that brings us to our second big technique, feature selection. I like to think of this as the art of decluttering your data. Feature selection is all about figuring out which of your features are actually important and then just getting rid of the rest. You want to throw out anything that's just noise because you don't want your AI getting confused by useless information. And why is less sometimes more? Well, by focusing only on the good stuff, you help prevent a huge problem called overfitting. That's when the AI starts memorizing the noise in your data instead of learning the actual pattern. Plus, a simpler model is way faster to train and a lot easier for us humans to look at and understand. For example, let's say you're trying to predict house prices. A feature like a unique ID number or a serial number for each house is completely and utterly useless. It has zero predictive power. So a data scientist will chop that right out so the AI can focus on what actually matters, like the square footage or the neighborhood. So we've created some new features, we've selected the best ones. Now for the final step in our data kitchen, we've got to prep those ingredients for the model itself. This step is called feature transformation. Think of it this way. You have to chop vegetables before you can cook with them, right? Well, you often need to change the format of your features too. A lot of AI models are kind of picky. They might not like really big numbers, or they might only understand numbers and not text. Transformation is just getting everything into the right shape for the model to use. And this is so important. Imagine you have two features, a person's age, which might go from, say, 1 to 100, and their annual salary, which could be in the hundreds of thousands. Because the salary numbers are so much bigger, the AI might accidentally think that feature is way more important. So we transform the data to put everything on a level playing field, which helps the model learn way more effectively.
A really common way to do this is called normalization. You're basically just stretching or squishing your data so that all your features fit neatly into a standard range, like 0 to 1. The relationships in the data don't change at all, but the new format is just much easier for many AI models to digest.
So there you have it. Those are the 3 core techniques in our AI Chef's Toolkit. Let's pull them all together for a quick summary. So let's recap the recipe. First, you have construction, where we create powerful new features like BMI. Second, you have selection, where we trim the fat and get rid of useless junk like an ID number. And third, you have transformation, where we get all our ingredients prepped and ready for the model. That's it. That's the 3-step process for high-quality data. And if there's one thing you take away from all this, it's this. A great AI prediction is not made at the very end. It's decided way back in the data kitchen. All the careful prep work, that's what determines the quality of the final result, long before the AI ever gives you an answer. Which, leaves us with a pretty interesting question for the future, doesn't it? As AI keeps getting more powerful, are the biggest breakthroughs going to come from building bigger and more complex models, bigger brains? Or will they come from the creative art of finding better recipes and just getting smarter about how we prepare our data? Something to chew on. Thanks for tuning in.